Hey there, I'm Mr. Thomas. Let's look at the model for Uganda's population growth, and this is since 1950. I think I have a pretty good model here. You can see that this blue curve goes through the dots pretty nicely. A few dots are a little bit below, a few are a little bit above, but generally it seems to fit the data well. The value for A is 5. That's my multiplier out front. That's my starting point. And my value for C is 0.0459. That's my growth rate. So I've got that in my exponent multiplying by x. So as I change that C, I get different sort of steepnesses of the curve. So I feel like the model fits pretty well, but the question is, what does it tell us? What does it tell us as we go out a few years? Specifically, I want to look at 2030. So that's going to be when x equals 80, because 1950 plus 80 is 2030. So let's go ahead. I'm going to scroll down. In 80, my function gives me a value. I can see it here perhaps of 63.7. That's 63.7 million people. And actually, I can go ahead and graph that point here. So the population is 2030 is way up here above 60 million people. That is more people than live in Italy in 2019, almost as many people as live in France in 2019. That's a lot of people. You can see that's a lot of population growth, and that's good information for the government of Uganda, for nonprofits, for businesses to understand. They need to make sure that there is housing, water, roads, schools, jobs for people fitting a population that size. It's a lot of work ahead of them, but at least they understand the magnitude of the challenge in front of them. So that's how the model looks, and one bit of what it can tell us. Notice I'm not going to try to figure out what the population is in 2100, right, in 90 years or 80 years. I'm only keeping it to something relatively close because things could change. This model is really good, I think, now, and will probably continue to be good for a while, but it probably won't be perfect beyond several years from now.